Welcome to the video training lesson on cross-site scripting. In this video, we will go over the basics of cross-site scripting and how to find and exploit them. First, we will figure out how to use a reflected cross-site scripting in order to print a message on the victim machine. Then, we will use a stored cross-site scripting to steal someone's cookies and then log in using their session. Our target website will be the web application Mobile Tech, hosted on the domain xssvictim.site. Note that this application is installed in our local environment, so it's not available online. The first thing to do is to navigate the application in order to find a possible vulnerable injection point. On the top of the website, we can see a search field. This is usually one of the first targets of our test. We will keep this field in mind while we continue to inspect the application. At first glance, in the home page, there's nothing else we can use for our purpose. So let's move on and click on Blog. This page is much more interesting since the application offers the user the possibility to write a comment for a specific post. Right now, we are logged in, so we are not able to write any comment. But as we will see later on, once logged into the application, a few more input fields will appear. Since we have two possible injection points, the search field and the comment fields, let's move on and get our hands dirty. Let's focus on the search field. The first thing to do is to test the search box and see how it works. So let's type something in there and then click search. As we can see, we have one post that matches our query. But as we can see at the top of the results, it seems that our search input is also printed in the result page. This is a very common behavior for web applications. What we can do now is check if the input is sanitized before being printed on the page. A very simple test that we can run is typing from HTML tags in the search field in order to verify how the application returns the results. So let's try to type the tab <h1 greater than hi less than /h1 greater than and see what happens. As we can see, it seems that the input is not sanitized at all. Indeed, our tag is interpreted by the application as a normal HTML tag. If we inspect the source code, we can see that the HTML tag is there and working. This is good for us. The next step is to verify if JavaScript code works too. A very simple code we can use to test it is the following. This simple code, if correctly interpreted by the application, will display an alert box on our browser. So let's run our search and see what happens. Great, it works. This means that the application doesn't sanitize any of our inputs and that it's vulnerable to reflected XSS. To do this, we can use the following code. If we check the source code of the page, we can see that it is correctly interpreted and loaded in the page as JavaScript. Now let's try to print something more interesting. This time, instead of printing a message, we tell the application to print out the cookies by using the function document.cookie. This is how the web server authenticates us during our session. Great. As we can see, it displays our PHP session ID. Now that we know this behavior, we can craft any payload we want and then lure our victim to open a link containing this payload. As we will see later on, we can craft a special JavaScript payload that takes the victim's cookies and sends them back to us. As you can imagine, if the victim is logged in the application and we are able to retrieve his cookies, we may be able to impersonate his session by changing the session cookie into our browser. Before seeing how to do this, let's first check if the comment field we saw on the blog page is vulnerable too. First of all, we need to log in order to write a comment. We already have an account, so let's open the login page and type our credentials. As we can see, we are now authenticated in the web application as an attacker. Let's open the blog page once again. Now, we can insert a comment in the application. Let's see if it works. Great. It seems we've successfully added a comment. Indeed, here we can see it. Now, we can start our tests. In the same way we did before the search field, let's type a simple HTML tag and see what happens. Let's focus our tests on the object field, and then, if this is not vulnerable, we will move on to the comment field. As we can see, the application works differently from before. It seems that the input of the object field is sanitized. Indeed, it's not interpreted as an HTML tag. But we still have to test the comment field, so let's use the same payload we used before. Great. This time it seems it's working. Indeed, the text we typed in the comment field is displayed differently. This happens because the application interprets the h1 tag. Let's now try to insert the alert JavaScript used before and see if it works too. Nice. As we can see, it works, and the pop-up appears in our browser. Of course, since this is a stored XSS, this message will appear every time we load the page. So let's delete the posts, otherwise we will get the alert every time. So now that we know the application is vulnerable to both reflected and stored XSS, let's try to exploit these vulnerabilities in order to steal the cookies of other users. In the same way we did before, let's try to print out our cookie instead of a message. To do that, we will once again use the function document.cookie. As we can see, the cookies are displayed in the alert box. What we want to do now is to steal the cookies of the users that visit this page. But since we don't want the victims to see the pop-up, we will not use the alert function. What we are going to do is to build an exploit that stealthily sends the cookie information to a website that we own and control. Before seeing the JavaScript payload, let's check the code on the attacker server. This is the script we are going to use in order to store the cookies on our machine. The code gets some information from the victim browser, then opens the file named jar.txt. Gets the value from the query string of the URL, and saves the information into the file. Of course, if we open the jar.txt file, we can see that right now it's empty. So let's then open the script into our web browser and see what happens. The file is hosted at the domain attacker.site, and the file name of our script is get.php. We just need to add a parameter and a value to simulate what our JavaScript payload will do. Once the page loads, the content of the variable should be stored in the file, jar.txt, along with the other information we set. Indeed, if we open it, we can see the string, "Here is my data." Now that we have a working script on our attacker website, let's create the payload that we are going to insert in the comment form. This simple script creates a new image object and then sets the address of the image to our website link. With this simple code, we trick the victim browser to request our attacker page and send the cookies. We use the escape function in order to avoid that special characters may break our link. It's worth noting that the victim will be completely unaware of what is going on. Now that we know what the script does, let's insert the comment and see if it works. Since the page is automatically reloaded, if it works, we should see our cookies stored in the jar.txt file. And here they are. So with this exploit, each time a user loads the page blog.php, his cookies will be sent to our script, and we will be able to read them. Let's then open the website from the victim browser. We will sign in with the admin credentials, and then we will browse the blog.php page. As we can see, nothing strange happens on the victim browser, so the user has no idea of what's going on. Let's go back to our jar.txt file and see what we've collected. Here we are. We have successfully stolen admin cookies. And now, we should be able to impersonate his session on the web application, meaning we will be logged in as admin. Let's copy the value, then go back to our attacker browser and edit the cookies with Firebug. To do that, we can just click on the Cookie tab, click Edit, and then paste cookies in the value field. Now, we just need to reload the page. And as we can see, we are authenticated as admin. Indeed, in the top bar, we can see a new link to the admin page. We can continue to navigate the web application as usual, logged in as admin. As you have seen, cross-site scripting could be very dangerous. And with that, we conclude this eLearn Security video training lesson on cross-site scripting. Thanks very much for joining us.